what are chemical equations and reactions. Let us look around ourselves and observe some activities in our surroundings, like the rusting of iron, souring of milk, explosion of crackers, metabolism of food, and so on. In all these activities, the initial and the identity of the substance have somewhat changed. The change may be physical or chemical. Whenever there is a chemical change, we say a chemical reaction has taken place. Now, what is a chemical reaction? Let us define chemical reaction in simple terms. A chemical reaction is a process in which one or more substances, the reactants, are converted into one or more substances, the products. Chemical equations. Say you have to describe some chemical reaction to someone. Say you have to describe the magnesium ribbon experiment. You may describe it as, when magnesium ribbon is burnt, it burns with dazzling white flame and it is converted into magnesium oxide, which is the white powder. This is well explanatory and informative, but it is tedious to write and it is quite long. So we use simpler and smaller techniques called the word equation to represent chemical equations. Now let us represent the magnesium ribbon experiment using the word equation. Magnesium plus oxygen giving rise to magnesium oxide. In word equation, the reactants are written on the left hand side and the products on the right hand side. The reactants and the products are separated by an arrow. The reactants are separated by a plus sign. If there are more than one product, they are separated by a plus sign. The direction of the arrow is directed towards the products and it shows the direction of the reaction. We know we can write a chemical equation by the word equation. We can make it more simpler by representing the elements using the formula, like Mg plus O2 giving rise to MgO. In this equation, let us count the number of atoms on the left hand side of the arrow and the right hand side of the arrow. If the number of atoms are same on both sides of the arrow, then we say it is a balanced chemical equation. If not, we say it is not a balanced chemical equation. This type of equation is called a skeletal equation. Balancing chemical equations. Let us recall law of conservation of masses. Law of conservation of mass states that the mass can neither be created nor destroyed. In chemical reactions, the total mass of all the elements in the products should be equal to the total mass of all the elements in the reactants. Thus, there is a need for balancing a chemical equation. Now let us perform an activity. Let us make zinc react with sulfuric acid, and the products of the reaction are zinc sulfate and water. Now let us take the equation of zinc reacting with sulfuric acid. When zinc react with sulfuric acid, we get zinc sulfate and hydrogen. Now in this reaction, let us note down the number of elements on both sides of the arrow and tabulate them. Let us make 3 columns: element, number of atoms on the right hand side of the arrow, number of atoms on the left hand side of the arrow. In element section, let us note down all the elements in the reaction: zinc, hydrogen, sulfur and oxygen. The number of atoms in the reactants: zinc 1, hydrogen 2, sulfur 1, oxygen 4. Now let us move on to the number of atoms in the products: zinc 1, hydrogen 2, sulfur 1, oxygen 4. We observe that the number of atoms in the product side is equal to the number of atoms on the reactant side. Hence we say this is a balanced chemical reaction. Now let us balance a chemical reaction. Let us take up the equation Fe plus H2O giving rise to Fe3O4 plus H2. By looking at the equation, we can say that it is not a balanced equation, or it is a skeletal equation. Now let us try to balance the equation step by step. Step 1. Now let us draw boxes around each formulas. And remember, we should not change anything inside the boxes while balancing. Step 2. Let us list the number of atoms in the reaction and tabulate them. Let us form the table: element, number of atoms in the reactants, number of atoms in the products. In element side, the elements are Fe iron, hydrogen and oxygen. The number of atoms in the reactants: iron 1, hydrogen 2, oxygen 1. Now moving on to product side, iron 3, hydrogen 2, oxygen 4. Step 3. Now let us start balancing the equation. It is preferred to choose the element or the compound which has more number of atoms in it. The compound may be in the reactant or the product side. And in that compound we choose the element which has more number of atoms. In this example, we take Fe3O4 as the compound and oxygen as the element. We see that there are 4 atoms of oxygen on the right hand side of the equation and only 1 atom of oxygen on the left hand side. To equalize the number of oxygen atoms, we cannot change the formula nor change the compound. We have to introduce a numerical coefficient. Hence we introduce a numerical coefficient 4 on the left hand side of the equation. Now the equation becomes Fe plus 4H2O giving rise to Fe3O4 plus H2. Now the equation becomes Fe plus 4H2O giving rise to Fe3O4 plus H2. This is a partially balanced equation. Now let us move on to the next step. Step 4. Iron and hydrogen atoms are yet to be balanced. We can choose any of these atoms. Let us take the hydrogen atoms and try to balance it. Let us tabulate the number of atoms on both reactants and the product side. On the reactant side, there are 8 hydrogen atoms. On the product side, there are 2 hydrogen atoms. To equalize the number of hydrogen atoms, we introduce 4 numerical coefficient on the right hand side of the equation. Thus now the partially differential equation becomes Fe plus 4H2O giving rise to Fe3O4 plus 4H2. Now let us balance Fe atoms. Step 5. Let us take the last element iron and try to balance it. We can see that there are 3 elements of iron on the right hand side of the equation and only 1 element in the left hand side. To equalize, we just put 3 on the left hand side of the equation. Now the equation becomes 3Fe plus 4H2O giving rise to Fe3O4 plus 4H2. Step 6. After balancing all the elements in the equation, we can check it by counting the number of atoms on LHS and RHS. Now let us tabulate again. Element number of atoms in the reactants, number of atoms in the products. Iron, hydrogen, oxygen. Number of atoms in the reactants, iron 3, hydrogen 8, oxygen 4. Moving on to products, iron 3, hydrogen 8, oxygen 4. Now we can see there are equal number of atoms on both sides of the arrow. Hence we can conclude this is the final balanced equation. This method of balancing is called hit and trial method. Remember, we should always use the smallest whole number coefficient to balance any equation. Writing physical states. Let us see these two equations. They are balanced, but they are not explanative. That is, they don't give any information about the physical state of the element or the compound present in the equation. To make it more informative and explanatory, we write the physical states next to the compound or the element. Physical states are represented within the brackets. For gaseous, we represent it by small g. Liquids we represent by small l. Solids by small s. And aqueous solutions by aq. Aqueous means the product or the reactant is present in a solution of water. In the equation, temperature, pressure, catalyst and other reaction conditions are mentioned above or below the arrow. To make it more informative, let us see the examples. The catalyst is represented above the arrow and the temperature above the arrow. Types of chemical reactions. We know that atoms of one element does not change into atoms of another element, nor atoms disappear from the mixture and appear elsewhere. What happens in a chemical reaction is there is making and breaking of bonds between the atoms. There are large number of reactions and all these reactions come under these 4 types, and they are combination reaction, decomposition reaction, displacement reaction and double displacement reaction. Effects of oxidation. Corrosion. We see that iron loses its shiny texture when used for a long period of time. It is converted into brown powder, simply called as rust. Even other metals like silver and copper, when come in contact with moisture or other acids, gets corroded, and this process is called corrosion. Corrosion causes damage to car bodies, ships and all other substances which are made up of metals. Corrosion of iron is really a serious problem. Large amount of money is spent to replace them periodically. Rancidity. Fats and oils after oxidation become rancid. That is, they taste and smell different. To prevent rancidity, we use antioxidants, airtight containers and gases like nitrogen. Now, how do we come to know whether a chemical reaction has taken place or not? Let us perform some experiments in our virtual lab with our friend Professor Proton. He will be helping in all our experiments. Experiment 1. Let us take magnesium wire and burn it. We observe that magnesium wire burns with dazzling white flame, and we can see that it is converted into a white powder. Now let us perform magnesium ribbon experiment. Proton. Now take a pair of tongs. Place the magnesium wire and heat it over a spirit lamp. We observe that the magnesium wire is burning with dazzling white flame, and we also saw that there is a white powder collected in the dish. This is due to the reaction of magnesium with oxygen, and the white powder is magnesium oxide. Now moving on to the next experiment. Proton has a conical flask with zinc granules in it. He is taking a test tube of hydrochloric acid and adding to the conical flask. We observe that hydrogen gas is evolved, and we also observe that the conical flask is heated up. Moving on to the next experiment. Professor Proton has two test tubes, one containing the lead nitrate and another the potassium iodide. Now he is adding the potassium iodide to the lead nitrate solution. As soon as the mixture mixes, it turns into bright yellow color. Just observe it. Thank you, Proton. Now, after observing all these experiments, we saw that there was change in color, change in temperature, evolution of gas, and change in state. All these factors determine whether a chemical reaction has taken place or not. Combination reaction. Proton now take a beaker and place calcium oxide in it. Add water slowly to it. Now we see that calcium oxide reacts vigorously with water, and the products of the reaction are calcium hydroxide. Now we also observe that large amount of heat is evolved during the reaction. This can be felt by touching the outer surface of the beaker. We saw that calcium oxide and water combined together give a single product, calcium hydroxide. We also observed that there was large amount of heat evolved. So the reactions in which heat is evolved are called exothermic reactions. Let us look into some more examples. Burning of coal. Carbon plus oxygen giving rise to carbon dioxide. Formation of water. Hydrogen plus oxygen giving rise to water. In all these reactions, two or more reactants combine to form a single product. These type of equations are called combination reactions. Decomposition reactions. Decomposition reaction is quite opposite to that of a combination reaction. In decomposition reaction, one single compound breaks down into two or more other compounds or elements. In decomposition reaction, there is a need for energy source such as light, electricity or heat energy. Let us perform an experiment. Let us take calcium carbonate in a test tube. Now let us heat the test tube over a spirit lamp. We observe that calcium carbonate is decomposed into calcium oxide and carbon dioxide. And the reaction is calcium carbonate decomposing to calcium oxide and carbon dioxide. Now moving on, let us take lead nitrate solution in a test tube and burn it over a spirit lamp. We observe that there are brown fumes around the test tube. This is because of the evolution of nitrogen dioxide. Lead nitrate upon heating gives lead oxide, nitrogen dioxide and oxygen. This is an example for decomposition reaction. Proton. Now take a china dish and place silver chloride granules in it. Proton. Now go keep the dish near the window such that the sunlight falls on it. Proton. Now come back. Let us perform an experiment. Proton. Now take a plastic mug and drill 2 holes in it. After drilling 2 holes, place 2 electrodes into it. After placing the 2 electrodes, connect it to the battery. After connecting it to the battery, pour some water into it and add sulfuric acid in small amounts to this. Proton. Now take 2 test tubes of water and invert them and place it on the electrodes. Now switch on the battery such that the current flows through the electrodes. After some time, we observe that there are bubbles displaced at each tubes. This is because the water has displaced into hydrogen and oxygen. Now we observe that water decomposed into hydrogen and oxygen. Remember, earlier we kept a dish into the sunlight. Proton, now get the dish back. Do you observe any difference? Yes, the white crystals of silver chloride has changed into grey color. This is due to the decomposition of silver chloride into silver and chlorine. In all these experiments, we saw that we use some sort of source of energy like heat, electricity or light. Hence, the reactions in which heat is absorbed are called endothermic reactions. Displacement reactions. A displacement reaction is a type of a reaction in which more reactive element displaces less reactive element from its compound. Let us perform another experiment. Proton, now take 2 iron nails. Proton, take 2 test tubes of copper sulfate solution. Proton, now dip the iron nails into the copper sulfate solution. After some time, proton, now remove the iron nail. We observe that the iron nail has turned into a brown color and the copper sulfate solution, which was initially blue in color, has faded. By this we can say that iron has displaced copper from copper sulfate solution. That is, iron is more reactive and copper is less reactive when compared to iron. Thus, iron displaced copper from copper sulfate. Let us see other examples. Zinc reacting with copper sulfate solution, giving rise to zinc sulfate and copper. We see that zinc has displaced copper from copper sulfate solution. Let us take another example. Lead reacting with copper chloride solution. Lead has displaced copper chloride and we get lead chloride and copper. In these two reactions, we see that zinc and lead are more reactive elements than copper. Thus, they displace copper from its compounds. Let us perform an experiment. Proton, now take 2 test tubes. Fill one with sodium sulfate solution and the second one with barium chloride solution. Now let us mix these 2 solutions. After mixing, we see a white precipitate formed. This is due to the barium ions and the sulfate ions. The white precipitate is the barium sulfate. We saw that there was an insoluble solution present in the beaker. This insoluble solution is called the precipitate and the reaction is called precipitation reaction. Combination reaction: A plus B giving rise to AB. Decomposition reaction: AB giving rise to A plus B. Displacement reaction: AB plus C giving rise to AC plus B. Double displacement reaction: AB plus CD giving rise to AC plus BD. Oxidation and reduction. Let us take copper in a dish and heat it. When copper is heated, it turns into a black copper oxide. Now let us pass hydrogen over the copper oxide. This causes the reaction to be in the reverse direction and we get back copper. Now let us observe and study this reaction. If a substance gains oxygen, it is said to be oxidized. If a substance loses oxygen, it is said to be reduced. Here we can see copper oxide is losing oxygen and is being reduced, and hydrogen is gaining oxygen and being oxidized. If one reactant is oxidized and the other reactant is reduced, it is called oxidation-reduction reaction, or in short, we call it redox reactions. Let us see some other examples of redox reactions. Zinc oxide plus carbon giving rise to zinc plus carbon monoxide. Magnesium dioxide plus HCl giving rise to magnesium chloride, water and chlorine. From these reactions we can say that if a substance gains oxygen or loses hydrogen, then it is oxidized. If a substance loses oxygen or gains hydrogen, then it is reduction. Now you might have been confused. Let us take all the points and put them in a table. Now this is clear and hope you understood oxidation and reduction. Now we have learned the types of reactions. Now let us understand them in a simple fashion.